So hello and welcome, and today we're going to be looking at the concept of balancing. So we're going to imagine that John is 30 meters underground and is traveling upwards at 5 meters every second, and we have the expression minus 30 plus 5t to tell you where he is. We're going to imagine that Mary is 210 meters above ground and is traveling downwards at 7 meters every second, and we have this expression here to tell us where she is. So, and unfortunately it doesn't quite fit here, this. We have Mary starting at time 0. Mary is here at 210 meters above ground, and at time 0, John is here at minus 30 meters below ground. So what I want to find out is, when are John and Mary at the same place? So what we can do is we can just put some values in and find out where John is at that time and where Mary is at that time. So let's try t is equal to 10. So we find out that John is at minus 30 plus 5 times 10, which is 50, and that's equal to 20. So John is now at 20, and Mary at t is equal to 10 is at 210 minus 7 times 10 is equal to 210 minus 70 is equal to 140. Okay, so after 10 seconds, we find that Mary is here at 140 meters. This is Mary now, when the time is equal to 10 seconds. And John is here at 20 meters at the time 10 seconds. So he's here at 20 meters. Okay, so we're going to need to pick another number. Needs to be more. John is still traveling upwards. Mary is still traveling downwards. Let's try another number and see where they are at that point. Okay, let's try t is equal to 20. We get minus 30 plus 5 times 20 is equal to minus 30 plus 100 is equal to 70 meters. When we try t is equal to 20 for Mary, t is equal to 20 means that after 20 seconds, we find that Mary is at 210 meters minus 7 times 20 is equal to 210 minus 140 is equal to 70 meters. So after 20 seconds, Mary is here and John is also here. So that worked out very nicely. We found out after just 2 guesses that at time t is equal to 20, Mary and John will be at the same place. However, sometimes it's going to be a lot harder to find out what the correct value is for where they are in the same place. So what we're doing is we're finding John's going up, Mary's going down, and sometimes they go past each other and then have to come back again, and you'd be going up and down until they're balanced. But what we're trying to do is we're trying to find a place where they're both in exactly the same place. And when they're both in the same place and the value for John is the same as the value for Mary, we say that they are balanced. Now, for several thousands of years, the way that you would measure the weight of something is you put the weight on one side of a scale and you put the other weight on the other side of the scale, and when they were both balanced, you would know that the weight of this one was the same as the weight of this one. So it would have been very obvious to people for thousands of years what it meant to balance a weight. That's not so much obvious to you, but you can think of it as a seesaw. On the left hand side, we've got John's value, and on the right hand side, we have Mary's value. And the way that people would measure things and weigh things is they would add weights. So if I added 10 grams to one side, I would know that I would have to add 10 grams to the other side to keep it in balance. So the whole idea about a balance scale was to keep it balanced, and you could eventually figure out exactly what weight you had. So let's see, what is John's value? We're going to use the expression for John's value, minus 30 plus 5t, and we want that to be balanced with Mary's value, which is 210 minus 7t. So in order for it to be balanced, we need to find some specific but unknown value for t. And the way we're going to do that is we're going to use a method called balancing. Like I said here, if you're on a seesaw and you add 10 grams to one side and you add 10 grams to the other side, then they're still in balance, so this value on the left will still be exactly the same as the value on the right. What I'm going to do is I'm going to add 30 first of all to the left hand side. If I add 30 to the left, I have to add 30 to the right. Can you see why I'm adding 30 to the left hand side? Let's have a look at what this expression is after we add 30. Minus 30 plus 5t plus 30 is 5t. And this is on a seesaw, and on the other side of the seesaw we have 210 minus 70 plus 30. Remember, if I add 30 to the left, I have to add 30 to the right to keep it in balance. We know that it's in balance for some unknown value of t. We want to keep it in balance until we can guess more easily what this value is for t, because it's really hard to see here. That's why we had to guess values earlier. We guessed 10 and we guessed 20. We got lucky with 20. But if we'd started guessing at 5, 6, 7, 8, 9, 10, we would have been here a very long time. So that's why we're using the balancing method. Let's have a look what happens to this expression when I add 30. 210 plus 30 is 240. Minus 70 is still minus 70, but they're still imbalanced. What am I going to do next? Well, have a look. I'll show you what I do, and you can guess why I'm doing this. Well, what I'm going to do now is I'm going to add 7t. And of course, if I add 7t to the right hand side, I have to do exactly the same to the left, because it's like a seesaw. And if I don't do the same thing exactly to both sides, it'll no longer be balanced, and that doesn't help at all. So why did I add 70 to the right hand side? Well, I think you can guess that 240 minus 70 plus 70 gives us the value 240 all by itself. If I add 70 to 12t, if I add 70 to 5t, I get 12t on the left hand side. I now have some variable on the left and some value on the right hand side. I have some variable value, and that has the same value as some constant value, some number. I still want to know what is this value t, but now we can just remember what 12t means. It means 12 multiplied by some unknown value, and I know that this unknown value has to be the same as this known value, so this unknown value must be 240 because it's in balance. Okay, so how do I find out what this number is? Well, you can see that we've multiplied by 12. To undo that, we divide by 12, and I find out that my unknown number is equal to 20. And of course, we don't use squares, we just use the letter t. So I find out that t is equal to 20 is the number that I need in order for John's value to be in balance with Mary's value. And we use the balance method, which means that whenever we add something to the left side of the seesaw, we add the same exact thing to the right hand side. If I add minus 30, I'd add 30 to that side and to that side. If I add 70 here, I add 70 here. And you can see that the reason I did that is to end up with some variable value on the left and some constant or whole number value on the right hand side. And once I've done that, it's a very simple case of knowing it's 12 multiplied by some unknown value equals 240. And you can see that straight away what the answer is from primary school, but our method is going to be, if we've multiplied by 12, we're going to undo a multiplication by 12 by dividing by 12. So we say divide by putting over 12. If I do divide by 12 on the left hand side, I divide by 12 on the right hand side. How is that balancing? Well, if you imagine you had 12 things on the left hand side and the same value on the right hand side, if I divide by 12 and divide by 12, they'll still be in balance, so that's okay. So if I add a number, I have to add a same number. If I subtract a number, I have to subtract the same number. If I scale up or scale down, I have to multiply or divide by the same amount as well. This is called the balancing method, and it gives us the number that we want directly without having to do all the guessing that we might have done here. We got lucky with this. We guessed 20 almost immediately and we got our answer. But let's have a look at doing this a little bit more tidily without showing you the balance. Instead of showing you the balance, I'm going to use a symbol, the equality symbol, to say that the value of this is the same as the value of that. Let's try a few examples. Okay, let's try with an expression of 13 plus 4t. And we want this expression to have the same value as, let's just use a number to begin with, just so it's a little bit easier. We want this value to stay in balance with this value so that we can find out what this variable value should be, what the unknown value t has to be. Okay, so it's our balance method. What are we going to do? Well, I don't like 13. I'm going to take away 13. It's a seesaw. If I take away 13, I have to take away 13 here. As you can see with the expression, 13 plus 4t take away 13 gives us 4t on its own. 21 take away 13 is equal to 8. You can easily see that 4 multiplied by some number equals 8. You know straight away that this is going to be 2. But let's do our method. We divide by 4, because 4 multiplied by t divided by 4. Multiply by 4 and divide by 4, you're back to where you started. So t is equal to 2. Let's try another question. So this question is 120 minus 7t. This is an expression for some which has some meaning. We just not going to be told what it is in this question. I want that to be in equality with, I want it to be in balance with some other expression, 160 minus 90. What am I going to do? Well, I don't want numbers on the left, so I'm going to get rid of them. But it's a seesaw. If I'm going to take away 120 here, I have to take away 120 here. So 120 minus 70 minus 120 is equal to minus 7t. And on the right hand side, I get 280 minus 9t. Now, I don't want this variable part on the right hand side. How do I get rid of a minus 9t? Well, I add 9t's. If I add 9t to the right hand side, I have to add 9t to the left hand side. So minus 7t plus 9t is equal to 2t's, and that's equal to, well, they get 0, so that's 280. Again, what do I multiply 2 by to get 280? Well, you could just guess it, but instead of doing that, we say we multiplied by 2 and divided by 2 brings us back to where we begin. If I divide the left hand side by 2, I divide the right hand side by 2, and I find our unknown value is 140. What's a good idea here now is to check your answer in the original expressions. The original expression was 120 minus 7 times t. The second original expression was 160 minus 9 times t. So that's 120 minus 980, and this is 160 minus 1260, and 120 take away 900, equals minus 760, and 160 minus 1260 is minus 1160. And this is the point where I realize I've made a horrible mistake. So that's the reason we check our answers, to see that we should have got the same answer. So we go back here again and we realize I took away 120, so I had to take away 120 here. That of course would give me 40 minus 9t, which would give me 2t is equal to 40 over 2, which gives me t is equal to 20. If I checked my answer then, I get 120 minus 140 is equal to minus 20. And on the other side, you get 160 minus 9 times 20 is equal to 160 minus 180 is equal to minus 20. So our original expression will give us minus 20 when t was equal to 20. The second original expression would also give us minus 20 as a result. So the minus 20 is in balance with the minus 20. So that's the result that we expect. So my apologies for making the mistake there, but it's actually quite useful sometimes making a mistake to realize that you've done something wrong. What I did wrong was I took away 120 and I didn't take away 120, I added it here. So if I take away 120, I have to take away 120 here, and I went back through it. I found out that the unknown value t was equal to 20, which is cropping up quite a lot. And then I checked my answer in the original expression, and I found out that yes, the original expression evaluated to minus 20 and minus 20. So yes, that was correct. Okay, so always useful to check your answer. Once you get an answer, put it back into the original expressions to see if they were actually in balance. You won't necessarily know what the expressions mean, so we're just going to be practicing a few things, but you get the idea. You get rid of the constant part here, you get rid of the variable part here, and that brings you back to the situation where you have some unknown variable part is equal to some constant part, and that's the answer that you're looking for. So again, apologies for the errors, but it does help you to see why you should check your answers, and also to remember that you have to do exactly the correct thing as you work your way through, or you're going to get the wrong result. And this is why a method is useful. But anyway, I'm going to give you a number of expressions. I'm going to tell you that the value of one expression is equal to the value of the second expression, that they are in balance. You have to keep them in balance by adding the same amounts to both sides until eventually you can figure out what the unknown and missing number is. So the best of luck with that.